So this is a review of sections 1 through 3 of Unit 7 to prep you guys for the quiz that we're taking on Wednesday. So this first set of questions says state of three numbers can be the measures of the sides of a triangle. So in this one we're going to compare two sides to the third, compare two sides to the third, compare two sides to the third. So we've got 10 plus 7, that is 17, and that is greater than 9. So 17 is greater than 9, so that one is true. 10 plus 9, that's 19, and 19 is greater than 7. Then we've got 7 plus 9, that's 16, and 16 is greater than 10. So we can make a triangle out of those three sides. So over here for number 2, we've got 10, 17, and 7. 10 plus 17 is 27, and that's greater than 7. Then we've got 17 plus 7, that's 24. That's greater than 10. And then we got 10 plus 17, that equals 17. Now 17 is not greater than 17, it's equal to. So we cannot make a triangle with those three sides. The next one is number 3. Again, we're going to add these two together. 8 plus 9, that's 17. 17 again is not greater than 18, so this is no as well. And then we've got number 4. 8 plus 12, that equals 20. 20 is greater than 10. Then we have 12 plus 10, that's 22. That is greater than 8. And then we have 8 plus 10, that's 18, and 18 is also greater than 12. So this is yes. So now we're going to do the next problem set. It says state if each triangle is acute, obtuse, or right. So we're going to use our Pythagorean theorem here and compare a squared plus b squared to c squared. So on this one, we've got our longest side is the 16, so we're going to make that c. So we're going to do 4 square root of 7, and we're going to square that. We're going to add that to 15 squared, and we're going to compare that. Let's see how it relates to 16 squared. So when we square 4, that's 16. When we square square root, that gives us 7. So this is going to be 16 times 7, plus this is going to be 225, and this is going to be, 256. So 16 times 7 is 112, plus 225. That's going to be 337. And then this over here is 256. So when we compare these, our c squared is smaller than our a squared plus b squared. So we are going to say that this is an acute triangle. Over here on the right, number 6, again, we're going to compare this side and this side to the hypotenuse. So we're going to do the square root of 95 squared plus 7 squared, and we're going to see how that relates to 12 squared. So the square root of a square is, or the square of a square root is what was underneath the radical. This is going to be 49, question mark again, this is 144. So that actually is 95 plus 49 is 144. So these are equal to each other. So that tells us that this is a right triangle. The next problem on here, number 7, again, we're going to compare the two sides to the two legs to the hypotenuse. So we're going to do square root of 145 squared plus 10 squared. And we're going to compare that to 7 radical 5 squared. 7 radical 5 squared. Here again, this is 145 because you square square root, you just get the number that was under there, plus 100. When we when we square the 7, that's 49. When we take the 5 out from underneath the square root, because when you square square root, it gives you the number that was under there, that's 49 times 5. this is going to be 245, and 49 times 5 is 245. So because these two are equal again, this is yet another right triangle. Over here on the right now, we have our two legs again, 4 and 208. So we're going to take the square root of 208 and square that. We're going to take 4 and square it. And we're going to see how that relates to 15 squared. So, square root again, we get the number underneath there. 4 squared is 16. 15 squared is 225. So when we add the 208 to the 16, we get 224. And we're comparing that to 225. This time we can see that c squared is bigger than a squared plus b squared. So this is an obtuse triangle. So number 9, again, we have leg squared plus leg squared. We're going to compare it to the hypotenuse squared. So we got 6 squared plus the square root of 157 squared. I'm trying to figure out how that compares to 257 square root squared. So this is 36 plus 157 and 257 over here. Then 36 plus 157 is 193. And we still got 257 here. So this time we have again that our c squared is greater. So this is going to be an obtuse triangle. Over here for number 10, we have again our leg squared, 14 squared, plus 2 radical 39 squared. How does that compare to 16 squared? So 14 squared is 196. 2 squared is 4. So this is going to be 4 times 39. And 256 squared, 16 squared is 256. So here we have 196. And when we multiply 4 times 39, that gives me 156. Still going to compare that to 256 over here. So we've got 352 and 256. So we can see this time that 256 is smaller, so our hypotenuse squared, or our longest side squared, is smaller, so this is going to be an acute triangle. Starting with number 11, it says find the missing side of each triangle, leave your answers in simplest radical form. Okay, so with this one first, we have to figure out what our two legs are. So 4 and 14 are our legs. X is our hypotenuse because it's opposite the right angle. So we got 14 squared plus 4 squared equals x squared. So that's 16 plus 196 equals x squared. That's going to give us 212 is equal to x squared. We're going to take the square root of both sides. And when we do that, sometimes we're going to be able to leave it like that, sometimes not. So let's see if we have any factors here. So if we divide 212 by 2, that gives us 106. If we divide that 106 by 2, that gives us 53. So I can see here that this number is repeated. So that 212, that square root of 212 is actually the square root of 4 times the square root of 53. And we know the square root of 4 is 2. So our answer in simplest radical form is 2 square root of 53. That's our answer. Okay, over here for number 12. Again, we have our leg and our leg, and we know this is the hypotenuse because it's opposite the right angle. So we have 8 squared plus x squared equals 11 squared. That's 64 plus x squared equals 121. We subtract 64 from 121 and we get x squared equals 57. I just happen to know that 57 is a prime number. So we take square root of both sides, and that's going to be our answer. X is equal to the square root of 57. So let's do 13 and 14 now. So 13, again our legs are 5 and 7, so 5 squared plus 7 squared equals x squared. That's 25 plus 49 equals x squared. This is 74 equals x squared. So if we take the square root of 74, take the square root of x equals the square root of 74. If I divide 74 by 2, that gives me 37, and so that's a prime number, so I'm not going to be able to simplify that any more than that. So for number 14, again, we got our leg and our leg, so we've got x squared plus 10 squared equals 15 squared. So we have x squared plus 100 equals 225. If we subtract 100 from both sides, we get x squared equals 115. And when we take the square root of both of these, we get that x equals the square root of 115. Our next set of problems says find the missing side lengths. Leave your answers as radicals in simplest form. So first thing we have to look at in these problems is what kind of triangles are they? And I notice with number 15 that I have a 45-degree angle here. So this has to be a 45-degree angle. That means that it's a 45, 45, 90. And the only formula I have for that is h is equal to L radical 2. So then I just have to figure out what is L and what is h. So I know that V and these two sides are congruent because the angles are both 45 and 45. So we also know that V is 3 because this side down here at the bottom is 3. Then we know also that this is h because it's the hypotenuse. Hypotenuse is across from the right angle. So the formula for h is, and we're going to write u here, is equal to, and our leg was 3, radical 2. So there's our two answers for this problem. Number 16. Again, we have to look at this first and determine what kind of triangle is this. We notice a right triangle immediately, but it has a 30-degree angle, which means the other one has to be a 60-degree angle. Here again, we need to know our two formulas. So our first one is h is equal to 2s, and h is the hypotenuse and s is the short side. Then we have a formula for the long side. The long side is the short side times the square root of 3. So we need to look at what do we have in this problem. And we notice that this is opposite that 60-degree angle, so that's our long side. So we're going to use this long formula first. So we got the square root of 3 is equal to the short side, which is this one right here because it's opposite the 30. That's b times the square root of 3. So all we're doing here is dividing both sides by the square root of 3. So our b is equal to 1. Now we have to solve for the hypotenuse, and it says up here that the hypotenuse is 2 times the short side. Well, this right here is our hypotenuse. This was our long side. This was our short side. So our hypotenuse is a. So a is equal to 2 times our short side. We found our short side to be 1. This was our short side right here. So 2 times 1 is 2. So a is equal to 2. With number 17, again, we have to look and determine what kind of triangle this is. So we have a 30-degree angle here, so we know that this has to be a 60-degree angle. So once again, we're going to look at these sides. So the side opposite this 30 degree is going to be our short side. The side opposite our 60 is going to be our long side. And then this is opposite that right angle, so it's going to be our hypotenuse. Our formulas here again are h equals 2 times the short side. Hypotenuse equals 2 times the short side. The long side is equal to the short side times the square root of 3. So when we look at this problem this time, we see that we have the long side. So the long side is 8, so we're going to put 8 in here. And our short side was y, so that's y square root of 3. This is the problem where we have to work through and ultimately rationalize the denominator. So we're going to divide both of these by the square root of 3. So that gives us y is equal to 8 over the square root of 3. We cannot leave that radical in the denominator, so we have to rationalize it. So we're going to multiply both the top and the bottom by the square root of 3. When we do that, we get 8 square root of 3 over the square root of 9. And we know because 3 times 3 is 9. So we know that 8 radical 3, then the square root of 9 is 3. So that's our answer for our variable y. Then we have to solve for x. Y was the short leg, so all we have to do to this problem right here is multiply that by 2. So 8 square root of 3 over 3 times 2 is 16 square root of 3 over 3. So that is our variable x, and that was our hypotenuse. Let's go over here to number 18. So again, we need to see what kind of triangle this is. This is a 45 angle here, so that means this has to be a 45-degree angle here. These two sides will be congruent, so we know immediately that y is equal to 3 square root of 5. Our one and only formula for a 45, 45, 90 triangle is h is equal to L radical 2. So this is our h right here. These were our L's. As we work this problem then, we're going to solve for the hypotenuse, which is x. X is equal to the leg, which is 3 square root of 5. And we're going to multiply that times the square root of 2. So when we do that, we get x is equal to 3, and we can multiply these two things here because they're the same, square root of 10. So that is our answer for x. This was our answer for y. Our next problem is 19, and again, we notice that we have a 60-degree angle here, so this has to be a 30-degree angle here. And if we look opposite the 30, we know that this is the short side. Opposite the 60, this is the long side, and this is the hypotenuse. So our formulas again for this are h equals 2 times the short side. Hypotenuse equals 2 times the short side. The long leg is equal to the short leg times the square root of 3. So this time we notice we have h, so we're going to use that formula first. So that's 20 is equal to 2, and our short leg over here was n. So we're going to divide both sides by 2. So n is equal to 10. And this is our short leg. We're going to use that for the next part of our problem. So our long leg here was m, and our short leg was 10. So then we just plug that into the formula, and then we have m. So n was 10 and m was 10, radical 3. Number 20, again, we need to look at this and determine what kind of triangle it is. We have a 60-degree angle here, so we know this one's 30. So side opposite the 30 is the short leg. The side opposite the 60 is the long leg, and the side opposite the hypotenuse is the opposite the right angle is the hypotenuse. So again, we got our two formulas. H equals 2 times the short leg, and the long leg is equal to the short leg times the square root of 3. So we have the long leg this time, so we're going to use that formula. So we have 3 square root of 3 is equal to, and our short leg was y, square root of 3. This time we divide both sides by the square root of 3, and it's going to cancel them out on both problems. So y is equal to 3. Then we're going to plug that back in to solve for the hypotenuse, which is x. So h equals x here, so x equals 2 times 3, which equals 6. So x equals 6. Number 21, we have a 45-degree angle here, which means this would also be a 45-degree angle, which means these two sides would be congruent. So this time we have h here, and these two are L and L. So our one and only formula for this is h is equal to the leg times the square root of 2. So we do have our h, so we're going to say 3 is equal to, and I'm just going to go ahead and solve for x because x and y are the same, square root of 2. So I'm going to divide both sides by the square root of 2. And when I do that, it's gone from there. So I got 3 over the square root of 2 equals x. If you recall, I can't leave that radical in the denominator. So I have to multiply this by the square root of 2 over the square root of 2. When I do that, I get 3 square root of 2 over the square root of 4. And that's going to be 3 square root of 2 over 2 because the square root of 4 is 2. So that's the value of x, which means that's also the value of y. All right, number 22 over here. Again, this is a 45-degree angle here, and we got a right triangle, so it's another 45 here. So we know these two are congruent. So we already know that v is equal to 7 square root of 2 over 2. All we have to do is solve for u, and u is our hypotenuse because these two things are our legs. So, again, our formula is h equals L radical 2, u is h, and our leg is 7 square root of 2 over 2, and we're going to multiply that by the square root of 2. So that's going to be 7 times the square root of 4 over 2, which is equal to 7 times 2 over 2. That's 14 over 2, which equals 7. So our u is equal to 7. Our last two problems, 23 and 24. So 23, again, we've got 45 here, so we know that this also has to be 45 because it's a 45, 45, 90 triangle. These two legs are congruent, so we know that y equals 10. And if y equals 10, then this is our hypotenuse. Our formula is h is equal to the leg times the square root of 2. So this is then just x equals 10 times the square root of 2. There's our x and our y. Okay, so over here, number 24, we have a 60-degree angle here, which means this one has to be 30. So again, we're going to talk about these sides. So opposite the 30 is our short leg. Opposite the 60 is our long leg, and opposite the right angle is the hypotenuse. So we have two formulas here that we can use. We have h is equal to 2s, that's our hypotenuse, is equal to 2 times the short leg, and then the long leg is equal to the short leg times the square root of 3. Doesn't matter which one we use first here. So let's go for h. So that would be u is equal to 2 times our short leg, which is 6. So this is equal to 12. So u is equal to 12. Then we're going to go for our long leg. And our long leg is s radical 3. So L over there was v. Our short leg was 6 times the square root of 3. So there are our two sides solved for number 24.